66 million years ago, dinosaurs remained the thriving apex animals of the planet. Fossil records show they were organized into distinct, highly diverse biological provinces, continuing to dominate every major terrestrial ecosystem across the globe. Mammals existed during this era as small, shadow-dwelling creatures. Relegated to the ecological margins, they survived in the literal shadows of these giants. That hierarchy ended when an asteroid measuring between 6 and 9 miles wide struck the Yucatan Peninsula. The collision occurred at a site now known as Chicxulub, Mexico. The impact released energy equivalent to 100 million megatons of dynamite. It triggered magnitude 11 earthquakes and sent massive mega-tsunamis surging away from ground zero. While this localized destruction was apocalyptic, coastal floods and shockwaves alone could not account for the global disappearance of 75% of all life. The true extinction mechanism was the planetary chain reaction that followed the blast. Geologists identified a global marker called the KPG boundary. This thin, dark sediment band contains iridium and soot, evidence of planet-wide fallout. It formed when the impact vaporized subterranean gypsum, ejecting massive volumes of silicate dust and sulfate aerosols into the stratosphere. This aerosol veil blocked incoming sunlight, creating a freezing impact winter that lasted up to 15 years. Without sunlight, global photosynthesis shut down. Plants died off, starving giant herbivores, which in turn eliminated the food supply for apex predators. The impact winter acted as a brutal ecological filter. It favored only organisms that could survive without massive daily caloric intake or fresh vegetation. Fossilized fish bones from North Dakota's Tanis site provide a clear snapshot of the disaster's timing. The asteroid struck during a northern hemisphere spring. This timing was catastrophic for dinosaurs. Caught in the middle of reproductive cycles and post-hibernation periods, their energy reserves were at their lowest. Small mammals possessed different advantages. Because most were under 25 kilograms, their daily caloric requirements were a fraction of the dinosaurs. Their ability to shelter in underground burrows provided a second advantage, insulating them from the lethal temperature swings occurring on the surface. Diet was the final factor. These omnivorous mammals could survive by eating dead plant matter, worms, and insects, rather than relying on living plants. A specific biological profile, small, sheltering in burrows, and scavenging for detritus, met the narrow survival criteria of this ecological bottleneck. In the wake of the impact winter, the 160 million-year biological hierarchy was gone. The global stage was effectively empty of massive terrestrial competitors for the first time in the Mesozoic era. Scientists measure recovery speed using helium-3 isotopes. Arriving via a constant rain of space dust, they provide a reliable sediment timer. This corrected previous assumptions. Records show new marine life appeared in just a few thousand years. This rapid rebound led to a process of adaptive radiation. Surviving mammals diversified to exploit the newly vacant ecological niches left behind by the dinosaurs. Within 700,000 years, mammalian species grew to 100 times the size of their impact-surviving ancestors, filling roles as the planet's new dominant large-bodied taxa. The Chicxulub asteroid triggered a major shift in Earth's biological trajectory. The dark, freezing decade it caused became the catalyst for the rise and diversification of the modern mammalian world.